wonder how self-driving cars are a detect object, right? How self-driving car are detect object. Basically, how the Netflix are a recommend your a movie or any shows or anything, right? How we organize or they can happen. So, behind all the magics, like the secret language is algebra. Okay. In today's video, I will show you the math for power, the smartest machines around you. Okay. So, let's get started. In welcome to the channel. Hey everyone, I am Pratant, and welcome to this series where we break down complex math into simple idea of machines. And today we will starting about the linear algebra, right? Today we will dive into a linear algebra, and that's how help us to making a self-drive car. So basically, the recommended system in a Netflix and YouTube and any social media platform, right? And that's all we will understand the real world applications. Okay. So linear algebra is a branch of mathematics. Okay. Basically, the linear algebra it's a branch of mathematics that deals with vectors, 1D array, matrix, 2D array, and linear transformation, right? And linear transformation. These are all concepts are very important, but right? So linear transformations, vector, matrix. So understand one by one and all the concepts of that. Okay. So first, okay, okay. Now, so the real example. Okay. Let's get to understand the example. Imagine you have a smartphone, face recognition, right? You use the smartphone, okay? Smartphone. And in smartphone, you will see the face recognition. You lock your face, sorry, basically you lock your face with the face cam and they detect and they unlock, okay? So this is basically using the matrix, right? In a matrix, the face lock is used basically the matrix, and matrix is what will they what they do? Because they create a pixel value, right? It's more like matrix. How look like a matrix? Matrix one, two, three, two, four, six, and a one, two, seven, four. Sorry, this is okay. This is basically a matrix, okay? And there's a pixel value or beyond that, the recognition in the black and white, and they simply add many colors and they recognize your face or basically face or picture, and the smartphone become unlocked. That's the one of the best example. Basically another is the feature extraction. Okay, when you perform a feature engineering in a feature engineering, basically you when you train your model. So feature engineering is a very important topic, okay, because uh, except that feature engineering you can't train your model. So feature engineering basically feature feature extraction done with feature extraction also done with the matrix. That's all the concept, learn about matrix, vectors, linear transformation. They all around nothing but the that's a vector and using that. Okay, input data matrix. Okay, okay. So basically, let's understand the core concepts. So let's understand the basic building block. Linear algebra that every ML model use cases. Okay, basically, every uh, linear model use cases. Okay, every linear model use case. So divide it into different parts. So first is going to scalar. What is scalar? Scalar is a single number, right? When we talk about the scalar, Scalar is a single number. Scalar is a single number. Basically, it will be, it is in the perspective of we will train a model. So is a learning rate, right? Learning rate, it may be a 0.01. Basically, it's a single value, single number, right? Try to understand. Scalars in simple terms, is single value. It can be 1, 2, 3, 4, 5, 6, 7, 8. That's the example of a scalar value, right? And this is a learning rate. Learning rate basically used when you in linear regression, when you train a model with a uh, mm, unit train a model with logistic regression, near past neighbors, so all the concepts basically based on the scalar. Okay. In second term, you are going with a vector. Vector is basically the list of number, list of list of number. What does it mean? Let's example. You have a house price data set. Okay. Example, we have a house price data set, right? In a house price data set, let's create. We have a three bedrooms, okay, two bathroom, and 1200 square feet. Okay, so this is basically scalar value, right? This is a, bathroom, right? And this is area. So this is called a vector. Okay. Similarly, when talk about the matrix, and basically, in the form of let's start with the data set. Okay. We understand the data set. Uh, okay. So we have house price data set, house price data set. In which data set, we have a bedroom, right? Uh, bathroom and area. Okay. Area. So we have a two, three, four, five. This will bathroom is a one, two, three, and let's four. Okay, and area is a 1200, 1300, 1500, and this is a 1800 square in square feet. Okay? Square feet, square feet. So, what is a vector? Vector basically when you that is called a vector. Okay, the example. That is a vector form. Okay, when you will return in simple words 0 2 1 and 1200, this is a vector form. Okay, similarly when you talk about the matrix, so matrix is a basically 2D array. Okay, 2D array. That's 2D array basically number part is the all the concept of array we will learn in a libraries when we learn about the libraries in a Python. So, when talk about the matrix in simple term, this whole data set is called a matrix. Okay, matrix. That is simple as that simple, bro. That's a no worry about that. This simple concept of linear algebra, matrix, and this all the things. So, transpose, dot product, and multiplication. Okay, that's also transpose. Okay, let's this. Okay, so one more thing is transpose. Okay, dot product, dot product. Similarly multiplication. Okay, this all operation, transpose, this all comes we will learn next this all courses. But now just understand this is for a predicting output basically. Okay, so this is useful for a predict a output, right? Output. What is the output? Okay, so see that example. We have that bedroom, bedroom, bathroom, and area. when you get a price, right? So this anything that will be anything. So this price will be your output. Okay, this price will be your output. So for predicting your output, that's the transpose dot product in multiplication. That's more useful. So okay, now some understand the real examples. Okay, real world example that you understand more. Real world application. Okay, in real world application, when we talk about the real world application, so basically Google Translator. Google Google Translator. In a Google Translator, basically using the translate the sentence, right? Translate a sentence using using a vector embedding. Embedding. That's even useful when you learn about the NLP, data science and machine learning. That's the basically embedding are very useful to extract the word or sentences. Okay, that's NLP, in a NLP, we are going to learn about the tokenization for basically separate out your or separate out data. So basically separate out your sentences. So this is for a Google Translator. Second example, we are going with a self-drive car. So best example, sorry, this is for a self-drive cars. In a self-drive car, right? This is a matrix sensor. Okay, matrix matrix sensor data. In self-drive car, what do you just think about that? How the basically the machines are how to detect the segments where to stop, basically where to stop, and someone came in front of car. So how the particular time stop, and all the recognition, how the machine are thinking. So this all about the matrix, right? This is all about the matrix and sensor data. Similarly for robotics, it's a best example about. Third one is the robotics. In today's world, many applications are based on robotics, right? In America, China, they create a robot that is based on basically that's type of data. Okay, so in a particular case, for a rotational matrix, okay, in robotics uses a rotational matrix, rotational matrix, and transformation transformation vector, transformation vector. They're all about the real world applications of a linear algebra and basically linear algebra. Okay, what is this method? Without linear algebra, you can basically, in simple, you can imagine the machine learning. That is a fact all about the and without training the model, existing model, without predicting a model, everywhere you will see the linear algebra is very important. Similarly, and the part of best part of you don't need. Okay? And we when we are learned all the concepts of machine learning. So in that concept, we don't memorize the things. Okay, memorize a thing, memorize thing. We simply understand because when you understand the concepts, so you will see you when you perform real world tasks. So you understand how the things are happening before because that don't memorize the thing, just understand what things are happening. Okay. For today's video, that's enough. And I hope you will like this video and understanding how the linear algebra work. In the next video, we will understand about some concept of a scalar and a matrix. Okay.